Hi, everybody. Good morning here in the room and good morning online. Um, let's see. Will somebody online just unmute and say hello if you can hear me? Thank you.
We got you, Julie.
Thank you. Thank you. Good morning.
Hi, yeah, we can hear you.
Yay. Okay, this is great. Hi, everybody. Welcome to Friday morning ESIP. We are super excited for this session. Eli Holmes from NOAA Fisheries and myself, Julie Lowndes from OpenScapes, we've coordinated this session about crossing the chasm, amplifying success stories about co-creating across institutions. And the reason we're here is, since our over the spring, Eli Holmes and I have been telling stories of crossing the chasm and telling success stories. We started doing this at a keynote at the Cloud Native Geospatial Conference after kind of iterating and mulling and testing over the years. But now we've been retelling this story across different parts of NOAA, across other open communities, giving other invited talks. We're really working on this story and seeing how everyone talks about the power of stories. We know the power of stories, but we've been really pushing ourselves to celebrate success and to prioritize that and to sort of push ourselves to iterate on this story the way we would on code. So these are real examples that we want to share and iterate with you and also tell stories in a compelling way so that you might turn around and retell the story, or you might fork this model and tell your own story, just like you would with code, right? So we convene this awesome group of stories in this session. So we're joined by Jen Schopf from the Texas Advanced Computing Center at UT Austin. Jen is a longtime ESIP member and community person, and we're super excited to have her join. I met her recently this spring and was just so stricken by this story, and so I'm so excited that you're going to be telling the story today. And UV is a co-founder of 2i2c and Project Jupiter. He's a longtime open source contributor in the Python world and far beyond. So you'll hear his story as well. So we're going to tell 4 stories of crossing the chasm with a short preface of what is crossing the chasm, what are we talking about, and then we'll have a plenary style discussion. So the 4 of us will be up here with our mics, and we'll be monitoring the chat. We'll be monitoring the collaborative note doc. So these slides are linked from there. Anything that's underlined is a link in these slides. Feel free to fork these slides, these stories, as we iterate. So it is my pleasure to welcome Eli Holmes from NOAA Fisheries. Take it away, Eli.
Take my timer, otherwise I will go over. I know myself. All right. Hey, really happy to be here. So happy to be at ESIP again. It's such a fun and social conference. So, Julie and I have a long history of doing both science and also teaching. And we made this little Venn diagram here of kind of where we overlap. And here we are. We do a lot of mentoring and teaching and empowering. And so today, as we said, we want to share stories about getting across this chasm between, you have your idea and you're really excited about it, and you have a community that's excited about that. And how do you get that idea into this broader target community that you want to get the idea into? You want this idea to spread. And yeah, we've been working together, since 2021. And doing a lot of thinking. This is just a little small encapsulation of our thinking over the years. If you want to see more talks, we have so many talks out there. We've given lots of different versions. And so today we're focusing really on this chasm. Like I said, so you have this it's not just an idea, you actually have your own community who's really excited about this idea. You come to, ESIP, you organize your session, and you have the people in the room, they're super excited. And then you want to get it over to the group of people who are not quite as, they haven't heard about your idea. Maybe they could be excited if they knew about it, but it feels like there's this big chasm. And this is a really common phenomena that between having the idea, it's kind of ready to go, and then you just can't get it adopted into your target audience. No, that's okay. I'm good. And that crossing that chasm is really hard. A lot of ideas fail there, or maybe they succeed in some version eventually, but there is still a lot of failures of trying, and things don't work, and and as Julie said, this spring we've been focusing on sharing the successes so that other groups that are over here in this early adopter period, they can see that it is possible to be successful and see examples of success. So I want to start off with this little parable that I use to talk about why that chasm develops. Why is it so common? And I want to use this sheepdog parable. So I want you to imagine the innovation is sheepdogs, developing sheepdogs to herd sheep. So this is completely a parable. This is not how sheepdogs were innovated, okay? But, so it's a parable. So the idea starts with this initial inspiration. So your innovator is watching these wolves go after elk in this case. And they have this crazy idea. It's not just impractical, impossible, it's like insane. They have this idea, it's like, wow, I could use that behavior to herd sheep, right? It's a leap of imagination. And so they have this initial idea. And so that's the beginning. So now how is that idea going to develop into, go from that, seeing that and thinking about wolves to your actual sheepdogs that could herd sheep? Well, the person who is the innovator, that human, is not really suited to this next step of turning that vision into reality. And part of it is that the thing that allowed them to do that leap of imagination is this fascination with these kinds of leaps, and they are not bothered in any way by the impracticality of the idea. In fact, it is often the case that the innovators are attracted to the impracticality. They find the wolf really cool, and they're really drawn to it. And that sort of personality is really important for them to be able to do these leaps of imagination and see things that other people simply could not see. But it prevents them from doing the next step, which is developing something which is really tractable, because the sheepdog is not as fascinating for them. So for this next step, we need to develop something practical and tractable. And as we go into that next step, there's a different personality type that is common to this process. It's very common. It is the early adopters. And these are people who see that idea, they hear it, and they have this relentless drive. It's a personality type to take ideas and turn them into workable products. And it's that process of idea to something workable that they are fascinated by. And in fact, they are often obsessed with this. It can be this creation step. It is often something that's difficult for them to resist. They just go deep. But that patience and skill and obsession to create like the pilot project is absolutely essential in the process of innovation. Okay, so now your early adopters, you've got your great early adopter crew. They have gone from the wolf, and now they have figured out how to create sheepdogs and how to train, specifically how to train these puppies to create sheepdogs that the sheep herders can use. Yay, we are ready to go. And now we're gonna sell it. And here we run into a really big problem because your early adopter, which are people, they try to sell the sheep raisers on puppies. They try to get the sheep raisers to love puppies. They're like, hey, it's a puppy, it needs training, that's okay, but training puppies is fun. What you need to do is learn to love training puppies. And the target population, the sheep herders, are like, I do not care about puppies. Again, these are people, and your early adopters are hearing this, they're trying to sell this, and they get really depressed by that. And next, the sheep herder's like, I do not want to train puppies. I don't like it, I am never going to train puppies. And now your early adopter just kind of dies. And in fact, it can get even worse. They can get more than slightly resentful of the target population because the target population does not love what they love. And that can really hinder that next step. And so kind of a typical thing that actually happens is, organizations or companies, it's really common. And this is really hard for companies that they may have to get rid of the early adopter groups, the people who put so much effort into it, but they may have to find a new place for those people, find a new thing for you to like do that early adopter stuff with, bring in other people who are connectors, who understand the target population. It's not just they empathize with they understand them, and they really enjoy sort of like fixing and solving the target population's problems. So it kind of, you get this social and operational barrier that happens going from these early adopters to your target. I'm within NOAA Fisheries, so I'm in a federal agency. We also have another barrier, and that is that our target population is risk averse. Like often, like our first target population is going to be leadership, because like I'm doing workforce development, and we're working, I'll describe in a moment, it's like workforce development, data science, and open science. And so in the next step, I need to get leadership to buy in and be supporting this from the top down. And leadership is risk averse, especially a large organization. They need to be risk averse. They are steering a big ship. They cannot be just running off different rabbit holes. And so there's this institutional barrier to trying new ideas, and you kind of need people who understand how to the role of like different types of pilots that will resonate with the leadership and what their goals are. All right, so that's my little brief, the short version of some of the people reasons that this chasm can develop. And now I want to go into an example of crossing that chasm and what that has looked like for the project that I've been involved with since 2021. So I'm going to talk about adoption of reproducible science and data workflows at NOAA Fisheries. And so when you hear this, think about like, creating, say, large reports and going from data everywhere, emails everywhere, my scripts, all my files named version, 1.0, version 2.0 final, version 2.0 final, really final, et cetera, and then think of a whole team that everyone's, files look a bit like this. And then, moving towards more scripted workflows, just more traditional, reproducible data science of workflows. So training people to do that and all that's involved. So first I'm going to start off with where we are today, and then going to back up and say, okay, well, how do we get there? So today, so I'm the lead of NOAA Fisheries Open Science, and it's focused on training and support. So my role is I'm going out, I'm NOAA Fisheries representatives on lots of different working groups around data modernization. That's a big theme for us. And I listen in, and I'm like, okay, you want to do that? If you want to do that, our technical and our science staff need to learn these skills. So how do we help them get those skills? And not just the skills, but actually how do we help them make change, right? You can have the skills and not change. We're trying to do both, get skills and change. And so today what it looks like is kind of these different pillars here. So we have a big part, which is community building. Well, we have 2 full-time staff, myself and John Peak. And then we have a big component that's skill building. OpenScapes works with us on that. That has a lot of different components, a lot of activities. We also support our infrastructure. We act in governance roles on this and support the people who are doing all the work needed to have this infrastructure. It doesn't just happen. We work with our cloud computing team, helping them in training staff to use this and doing, it's basically training and help support. We have lots and lots of weekly trainings of just a whole variety of types. And then we have our one-on-one and team support, which has turned out to be really helpful. All right, but we didn't get there immediately. It was a very slow process. And back in 2021, we had to come up with a strategy of how we get to today. It was, I think in 2022, I gave a talk at ESIP, and that was the first time, like I had been talking with Erin Robinson, and she mentioned this diffusion of innovation, and then I was doing a lot of research on that, and those ideas really resonated for me, and for me to think about what our strategy was. And a key part of that theory is that it's talking about the importance of the early adopters. So during 2021, I had to think about, well, have we fully reached the early adopter community? And I felt we were ready. I thought we had a really good group, but then I thought about it. I was like, wow, have we reached all those people? No way have we reached all those people. Knowing that they like to be able to get into into this sort of target population. So these are early adopters are eager. It's really easy to get them to adopt these things. But you start getting over here, this is work. And we really need a whole lot of these people in the organization. And we need them at every single science center. We need them in every team. Like, wow. So that was stepping back and realizing, okay, we were over here. I thought we were ready to just jump over there, and realizing, no, we had to go through this stage of developing the early adopter group, really focusing on the people who were receptive and eager and desirous of using the things, these sort of open science and open data ideas. So we spent like 2 years doing that development, really intentionally doing that development. And it was only after that that we began rolling out agency-wide. Okay, so whenever I talk about this, I talk about open science, invariably, people say, no, people don't want to try new ideas. What about this person who's never going to adopt that idea? And my response is, well, that person is not very relevant for adoption of new ideas and innovation then. Don't focus on them. That is not where you start. You're going to start with the eager, not just the willing. The willing say, you start there, that's too hard. No, start with the eager. The people, you tell them that idea and they're like, oh, wow, I need to go learn that thing. And then they just go off and learn it. You start with the eager. All right, so that's great in theory. But okay, how on earth do you reach the eager? So there's something interesting about the early adopters. It's a personality type, it's not a skill set. It's a personality type. And because, people can learn skills. They can learn skills. But it's a personality type, and this type, like they hear these new ideas and they become just driven and obsessed to develop that and create things. Like that person in the team who hears that, they're just like, oh my God, I have to do that. And they start creating things for their team. They start giving presentations, and they can't really stop that. But it's a rare personality type. So it's kind of a little bit of a needle in a haystack. They're often, if they're lucky, you're a team where there's a few of them, but usually it's not. Another aspect of early adopters is an interesting aspect I've observed over the years is it's not uncommon for them to be shackled in their work setting. The reason is that these people have a difficult time resisting the urge to become obsessed with things. They hear a new idea, it's very hard for them to resist that. It's a physical sensation. If you're one of these people, I'm one of these people, I know this sensation, I hear a new idea, it takes a lot of work for me to resist. Oh, I cannot sleep tonight, I must develop this, I must, everyone who knows me is like, yeah, Eli, you're like that. But it's a common feature of these early adopters. And when they're in a team and they're a junior person, their supervisor needs to shackle them. They need to control them. And so it's something I've observed over the years. It's very common. They often feel very isolated and they feel kind of like really pushed down, and it can make them really depressed. They may feel like, I have to leave science. It's not for me. I can't find my place here. Nobody else is like me. And so you kind of need to figure out how to find these people and how do you open it up so they can join you. And then once you get them together, you see they brighten up and the energy level is just like if you get a whole bunch of them in the room, it's really super fun. I run a lot of hack weeks, so bring these people together. All right, I'm almost done here, Julie. So, so, for us, growing that early adopter group in the very beginning, it meant finding allies, and working with groups that were, I identified, they're doing kind of open science-y kind of things. And there's likely early adopters there who'd be interested in working with us. So making connections, figuring out where we could synergize, right? So not saying, hey, you come help us, but rather figuring out what are our joint goals? How can we help each other? So allies were really, really important. User groups, super, super important. One of the most successful things we did was focused on developing an R user group. We'd had a few of those, but we made one for all of NOAA fisheries, and people within the open science group put a lot of effort in managing that, supporting that, and building that. And the reason was that group, it wasn't that they were necessarily doing open science, but they were doing open source. But the people who were interested in R and would join that group were more likely to be these early adopter types. So it ended up being a really great way to find the kind of people we wanted. Community, this icon here is talking about community. We just did a lot of community work. And I want to emphasize this feeling within the early adopter of feeling kind of pushed down. This is really kind of common. If you have new ideas, other people are like, I don't know about that idea, like that gets depressing. So it's really important to create this community so these people can come together and energize each other. That's part of this session here, like energizing each other about our successes. And that's really important. And then the last really big thing here was, I couldn't find a good icon for this. I'm a coach, and I'm a ski coach. And one of the things we talk about a lot is make a student-focused lesson. What does that mean? That means that you're not coming in and saying, hey, I got the plan here, you're gonna do this. Rather, you're trying to understand your student and understand what their goals and serve their goals. And it's kind of the same with this, that you're trying to understand your people's, what they're trying to do and help them. Okay, so last slide, I want to say 4 things that, 4 take-homes that I've found really important. One is this idea, start with the eager and then move to the willing. Second, remove barriers to joining your group. The more barriers you can remove, the better. Just make it super easy, no registration, nothing, everybody is welcome. That's super important. Really actively cultivating a culture of openness and helpfulness. That is super important. And then lastly, wow, you have to do 10 times more communications than you think you need to do. You're constantly communicating in lots of different ways. All right. With that, we want to hear some other success stories.
Thank you so much, Eli. It is so fun giving these talks, and they're different every time. Like, we iterate, we fork, we iterate. So I learn something every single time we do this, which is so fun. Okay. So I am, like I said, I'm Julie Lowndes. And I'm not going to be telling a Crossing the Chasm story today. So Amy Steiker, who is at the NASA NSIDC, the National Snow and Ice Data Center, she was supposed to be giving this talk, and she was denied participation in ESIP. So instead, 3 different talks from NASA folks are going to be sharing their talks at a community call we're going to have next week, that OpenScapes is going to host next week. So that is the place for you to hear many different stories about Earth access, but including this really critical Crossing the Chasm talk about Earth access and NASA Earth data. So I'll say, we have a big culture at NASA, OpenScapes, and our mentor community, which complements the community that Eli just described at NOAA. We have a big culture of sharing each other's talks, jumping in for each other, teaching. So I could very well give Amy's talk, but I thought this would be a good opportunity to not only create space for 3 of these Earth access talks next week, but also for me to reflect a little bit about this early part of that early adopter community building that Eli just described at NOAA, because this was happening at the same time back in 2021. So I'm just gonna just kind of talk out loud about some of the thoughts, and here's a couple slides that I threw together to go along with that. So this is back in 2021, and some of these slides are just copies from our earliest talks in 2021. So this one was from AGU, Aaron Robinson and I presented. Aaron Robinson and I led this effort. So our effort, and this is words from our proposal back in 2020. This was to support NASA Earth Science research team's migration to the cloud. This was the NASA OpenScapes project that we pitched we proposed in 2020, and then have worked on since then. And the overarching vision is to support the scientific researcher teams that are using NASA Earth data as they migrate their workflows to the cloud. And we were doing that by working with the NASA Distributive Active Archive Centers. They're called DACs, they're the data centers, over 3 years, by first developing a mentor community. So that's a community of early adopters Then to empower science teams that the mentor community interfaces with and is responsible for through, first of all, a champions program, which is one teaching mechanism that we use, but it ended up being many. And then also scale the ways we teach with the mentors. So that was the goal back in 2021. And really when we started back in 2021, we pretty early on, within the first 3 months, and I'll show a timeline in a moment, we needed to build common tutorials for teaching folks how to access data in the cloud. This is something that we got to through many conversations. So this is the Earth Data Cloud Cookbook is an open source, active, modular, open development tutorial collection that has purposeful documentation. This is also a slide back from 2021 that Amy Steicher actually created, and then we iterated from there. So this is common tutorials that are built in GitHub organization. They're using Quarto to collect the Jupyter notebooks. The code that's developed was through a collaborative effort across the different data centers of this mentor community. We had this really create once, use often workflow. It was really researcher oriented. And that took a lot of work to get here, right? We had weekly meetings with folks to welcome them into a Zoom room to help us not only talk about what was working, but what was not working, and having that kind of vulnerability. It took a while to be able to say out loud, oh, it's hard for you all to access the cloud. We need to work with 2I2C and partner with the community to manage a Jupyter hub so that we can all be in the cloud. We've never done this before. Let's learn this together. Let's turn around and write documentation to ourselves using, what are we going to use? Is there a GitHub org? No, let's create one. Does everybody know how to use GitHub? Let's create accounts together. How shall we do this? Jupyter Book was pretty early days at that point. I was coming from the R world and was pretty intimidated by Python and earth science, but I knew R Markdown, and I was in touch with, I'm getting ahead of myself. We used Quarto. We had to learn how to use Quarto. We developed with folks to learn Quarto. Anyway, I'm gonna make sure my timer's going because this is the storytelling. Okay, so this is a timeline of some early periods there. So this is the early adopter timeline here. We kicked things off in March 2021. We taught together just 6 months later in November 2021, we had our cloud hackathon. This is still just an absolutely transformative moment where we had mentors, we had people, teachers, these are people from 5 different data centers working together, teaching common tutorials with data that was representative for a community. Then we turned around and did this again with a big cohort in April and June 2022 with the Champions cohort. And there were other workshops happening in this period. But it was in these teaching events and through these experiences of working together through those weekly meetings with the mentors that, this is a group of early adopters, and one other, an early adopter who is, you sort of these personality types can blend, right? So like early adopter innovators, right? Okay, Luis Lopez, an amazing software engineer at NSIDC, was like, wow, I see something. I'm learning through actually teaching with other people, seeing what's hard. My peer, he was, seeing that from his peers within NASA, seeing what was hard, and also seeing what was hard to teach and what was hard for the users to learn. So he demoed Earth Access as a prototype in October 2022. And that's just an amazing, rapid turnaround of like getting this group together in a Zoom room and encouraging us to turn our cameras on in March 2021 to a working prototype in October 2022. And part of the reason why this all works is this developing early adopters takes so much time and energy. I mean, 10 times as much communication and like probably additionally 10 times as much coordination and like one-on-one responses, and let's, okay, a lot of work. So, but so that's on our side, but on the mentor side, we designed this, Aaron Robinson and I designed this whole project as part of these folks' paid time. This was an opt-in thing so that early adopters could, their supervisors knew about this opportunity and passed it on to their staff, knowing that it was going to be 20% of their jobs, because their jobs were to support users, and this was a mechanism to learn how to support users. So it was part of their jobs. So the way we did this was Aaron and I took a lot of different steps and were iterating and building, and we codified the steps we took to develop this early adopter community as our OpenScapes flywheel. And the flywheel, the concept of a flywheel is that it's this big, heavy thing that is really hard to push and move. You push it, you push it, you push it, there's no movement. But the 100th time you push it, it budges. And then you push it again, and you push it again, and it starts to store energy, and it will fly. And so we use this metaphor as a planning tool, as a reporting tool, as a way to think, as a way to say, like, ooh, this is a heavy part of the flywheel right here. Like, what's the next step? It's like looking at the chasm. So this is also an open source tool to use and fork. And the concepts around it, we wrote this down in 2022, but we've been iterating it since and continue to. But the idea is that you amplify those open leaders, those early adopters. You help welcome other people by engaging a future us mindset. And then you empower this learning culture forward. And there's details here on every different steps around the way. We think about these in like these three concepts and these like 6 actionable items. And to just kind of dig into some of them. So creating space and place is a really important one. I mentioned the Zoom room, I mentioned the GitHub organization, those things like need permissions and admins and but also as few barriers as you can. And one of the most powerful concepts we have here is co-working. Eli mentioned this a little bit as well, but these are, regular scheduled times on the calendar that people can get into with people that are not part of your normal team, right? This is a place to have, within an organization, to have cross-team awareness and cross-organizational learning, but also within a broad community, have cross awareness. So coming from the R community, I learned a lot about time series analysis from the finance folks who were developing these amazing packages that solve my, squid swimming problems, it was amazing. I'm a marine ecologist who studied squid, that for reference. So this is a group that can turn around and solve problems and also think about how to onboard others. So this 2021 Cloud Hackathon event was just one formative thing that came out of those co-working sessions. This event was a huge success on so many different axes. We had 65 different 2I2C Jupyter Hub instances working. We had that many people that completed the course with us, or the hackathon with us. Remember, this was 2021. We were all virtual. This was a virtual 5-day hackathon where we taught in the mornings and had hack time in the afternoon. It was a long time on Zoom, and people stayed and showed up for this. This was a high quality event that the mentors produced and taught. So it's just, and we learned so much. We saw what was hard from this as well, and continued to fork it. So the next point here is to really invest in that learning and trust. We designed, we learned from what had made us feel comfortable being vulnerable and saying what was hard from our own weekly meetings, and brought that to the hackathon. So hackathons are, they're these really powerful ideas, also a tool for bringing people together. The definition from the eScience crew that leads Hack Weeks really amazingly well. They define hackathons as tutorials plus peer-to-peer learning plus project team-based work all together. When you have developers and users coming together as a really well thought out teaching event, you learn a lot of things. You get a lot of generated ideas. You see the science questions people have and what's hard for them in the way we're organizing our data access. It's identifying the problem that's so painful that will help motivate us to cross the chasm. That problem so painful is really important. And for us, the problem so painful was that this previously unseen barrier. Okay, I'm just going to read this here. The core functionality for core functionality for data access, which was Earth data login authentication, efficient search and query via CMR, bulk download, and direct access from AWS object stores, that was insurmountable for many users via the code-based workflows required for cloud, right? So folks who may have had a workflow for their whole careers or were new to this whole space, who would be used to a download model and maybe using tools locally that they could click through, suddenly needed to use code. And if the first step of like, welcome to accessing Earth data meant that you had to run code like this, it was really challenging. And this was one of several different approaches that the different data centers had developed to support their users. Everyone was really trying to help users as best as they could within their immediate needs and their expertise and their toolkits. So everyone was building and innovating, but it was still really hard for users. And that was really unseen until this hackathon. And so this other point, this other part of the flywheel is about forking common workflows, skills, tools, ideas, bringing what you see in one place to another. And the thing that's really important here is partnering, and this idea of Eli was talking about allies and like who can help you. Like the early adopters maybe can't do it alone to meet the general population. How do you cross the chasm? This brings in new creativity and new resources. So there's many forms of contributors. Luis Lopez, who is the creator of Earth Access, he saw this in those hackathons and then again in the Champions cohort. He had 20% time through OpenScapes to interact with our community, to develop things, to teach. That wasn't enough for him to really prototype what he saw as this need. We were able to advocate for him to have up to 80% of his time to focus on prototyping this for the full summer, and then I think it was the summer. I think it was 3 months for 80% of his time. That's amazing. Like that was a barrier he saw. He asked for help, and we were able to help. We were meeting with leadership and being able to see barriers and remove them. So that was really important. We also partnered with software folks early on. So 2i2c is an amazing partner supporting Jupyter Hub communities across the world and developing something for one community that's hard for them and then being able to scale it out across all communities. So we've done a lot of development with 2i2c about, it's really hard, users should never have to have an AWS account. That's a part of the model for 2i2c. But how about if they don't have to have a GitHub account either? Like how do we bulk add users to our Jupyter Hubs without them needing a GitHub account, if that's a barrier for them in these earliest steps? We also worked with our studio in Posit. So I mentioned the Quarto book in the beginning, coming from our back in 2021, Quarto didn't exist yet, or it was in development. And so I was talking to JJ Laird, our studio, and telling him about this NASA work, and he was like, "We're trying to build. Our vision is to build our Markdown for natively for Python and Jupyter notebooks. Can you help? Can we work together?" And so they've developed a lot of features around Jupyter notebooks using our NASA Earth data experiences that we've been able to extend, and we continue to build on those relationships now with NOAA Fisheries and other features for Quarto. Cheat sheets art have been a big part of partnering and like being a little brave and doing something a little different. It's hard to show art in a place you're intimidated. So that's been something we've been learning. So what this partnering though for Luis meant, and there's so many more stories. These are just a couple stories. This was October 2022. Luis, in one of our weekly co-working sessions where people bring what they want to share and get feedback on. We have light structure. If there's nothing, we have light structure. Anyway, he showed, this was this moment where he showed Earth Access for the first time. And this chat window with the yellow box shows, people from 3 different data centers saying, hey, this worked with the data from my data center. Like, that's amazing. Very exciting moment. Okay, so this slide, the creating space for innovators and early adopters and users and people on all, people who are curious or might be willing and eager in those spectrums. Like there are structures that we can iterate from and support them through co-creation, hackathons, different teaching styles, co-working. The stickers for Earth Access are something that those hex stickers are really common in the art world. It's a way to visibly mosaic communities together. And, we brought that idea with Earth Access, and Luis Lopez designed this artwork with Allison Horst, who's done all of our other OpenScapes work and is an amazing artist and highly celebrated in the art community. So this is my final slide, just wrapping things up. This is about creating our own certainty within a group of early adopters and keeping that morale, that motivation up. This has been really, this is a really pretty miserable time in a lot of ways, and it's a really joyful time in a lot of ways. So there's a lot more to hear about Earth Access and a lot of the other NASA talks next week, so thank you. Now, Jen.
Hey, so I'm going to tell a story as well. Those of you who've met me know that I tell a lot of stories. I've been in a variety of positions. I'm currently at the Texas Advanced Computing Center, and I bridge to a number of science communities and help researchers use various cyber infrastructure pieces. But my story, unlike Eli's about the getting involved with the eager and the willing, it's about being the target of the desperate. So we're going to start 3 minutes on TAC, the Texas Advanced Computing Center. It's part of UT Austin. We're actually, ESIP is going to be there next summer. We're working out on how to have tours. You can go and see the giant machines. We've got over 200 folks there now. We bridge this chasm between, as I mentioned, the scientists and cyber infrastructure of all kinds. We have giant machines. We have lots and lots of storage. We have lots of users, over 4,000 active projects in 150 different fields, 80,000 annual web portal access, you name it, we've worked with it and we're planning to work with it. And unlike many of our colleagues, we're actually safe in even the presidential budget for the next phase of our project. We all have survivor's guilt, and we're also trying to figure out how do you exist in a world where you've got funding and your users may or may not. How can we help with that? Our big project right now is called the Leadership Class Computing Facility. This is going to be the largest NSF-funded computer ever. It's actually going to be located slightly up, north of where we are right now, but it puts high-performance computing and cyber infrastructure in the same class as NCAR, Vera Rubin, McMurdo, you name it, although, of course, several of those aren't great examples to use this week. So, how many people have heard of Arecibo? You've seen GoldenEye or Contact. This is the giant telescope that was in a volcano caldera. Started in 1963, ran continuously for over 50 years. But they had a lot of challenges. Some of these were planned or semi-planned. They had budget cuts. They had facilities issues. They had a change of management. It originally was Cornell. It shifted to Florida. And all of this took its toll. And also because the operations budget and the maintenance budget were one big budget. And if you got to choose which one are you going to spend money on, you're going to choose the science because it's run by scientists. Then they had a whole bunch of unplanned challenges. They had a hurricane, which cut all the networking. They had an earthquake, which had further issues. Then they had another hurricane. And again, science versus operations, deferred maintenance, all of this started adding up until they had cable snaps. This is actually a picture of a cable into a socket, and they eventually figured out that they had something called zinc creep, which meant that the cables were pulling away from the sockets. They actually noticed it as soon as, I want to say in the early 90s. The final cable snap actually happened on 2020. And this is what it looked like afterwards. That arrow is the data center. It missed the data center by less than 10 meters. The data center where 50 years of astronomy data was kept. The only copy was kept. So this happened in December 2020. They actually reached out to us in July or August and said, hey, we realize that, our data is a little bit at risk here. We're working with Central Florida and they're saying we should put it in the cloud. What does your team think? And we did a back of the envelope sketch and said, well, that's a great idea if you got 42 years, because that's how long it would take to move their 2.5 petabytes of data into the cloud with the connectivity they had at their data center. So not great. So then they said, well, maybe Central Florida can have this. And Central Florida was like, yeah, no, 2.5 petabytes of storage, that's like 3 times what we have for the entire campus. Can't do it. I was actually at Indiana at the time running a group that worked with researchers. We reached out to friends at TAC, and after 4 emails, got the TAC guys to say, yeah, we can find that. We can do that, we can help support this. So it took us 9 months, but we moved all of the data over, which was a crazy thing unto itself because the connectivity up on the mountain was almost zero, okay? They didn't even have cell phone connections, right? So what we wound up doing was having a detached storage device. We'd load it up on the spinning disk. We had 3 of these in circle. Someone would drive it 2.5 hours down the mountain to the coast where they had a 10 gig connection from Puerto Rico back to Florida, and then, take the old one, take it back up. And so there was this rotation of removable disk storage. And with all large data sets, we said, start this as soon as you can. We actually got a copy of the exact removable storage. They had 3 of there. They didn't, buy them new. They had them sitting around, so we didn't get a choice in this. We bought an identical one, tuned the hell out of it, figured out how to make it run faster, got them to use a protocol called Globus for file transfers, and we got about a 10-fold speed up, even just by tuning the device and changing how they were transferring the data. So 9 months later, 2.5 petabytes of data is moved. We think we're good. People are pulling it from TAC, not from Puerto Rico. They're making copies. This is great. We think we're done. We're not done because they had tapes. How many people have used tapes? Okay. Tapes. They had a lot of tapes. They had a lot of tapes that weren't organized kind of at all. Well, they were organized. They were organized with their placement in this room, which they swear stayed air conditioned even through all the power outages. But 6,000 tapes. We're like, okay, step 1, you're going to put a number on every single one. You're going to put a number on the tape. You're going to put a number on the box. You're going to start with whatever you want to start with and just increment. Put a number on everything so we can track everything. This is why you need librarians involved in your data collection. This was data collection by astronomers. Okay, what's even better is, I don't know, no. This has a project number on it, which is great, and a date, which is great. Not all of them did. Those project numbers are actually in a giant book where back you used to sign in, here I'm Jen Shupp, I'm here on Tuesday, or Friday, July, whatever we are, and I've got, 3 hours of telescope time tonight, I'm looking at this, and here's my project ID in a giant book, okay? Those were the lucky tapes. Some of them were marked things like Tuesday. So, step 2, for data movement, we actually shipped 5 guys down there. I was supposed to go, but I herniated a disc in my back a month before this and just got to see the pictures afterwards. And we scooped up 4 pallets of tape. So roughly 3.8 petabytes is what we figured. That's what it looked like. This is one of the guys pulling the tapes off of the storage. I actually have a whole slide deck of more pictures, which is almost as fun. And we got them shipped to Texas. They spent about a month curing to get acclimated to the Texas and our data center. And we've pulled data off of there on request. So what we have right now at TAC, we had them port their web page over, which they hosted on a VM when they initially did the spinning disk. And we can have the spinning disk and any of the tapes that we've uploaded. We've uploaded about 0.5 petabyte from request-driven requests. Nobody's used it for about 1.5 years. We're in the process of shutting it down. We'll hang on to the tapes and we'll hang on to the data. We just won't have their bespoke website because they've managed to make copies of it locally for their projects, which had been their plan and what NSF had contacted us about 3/4 of the way through to help us get this done. No, so I was asked, well, what is the bandwidth of shipping 4 pallets of tapes? It works out, I'm trying to get the exact how long the boat took, which I didn't write down anywhere. It's roughly 1.1 to 1.3 megabit per second. It took 5-6 weeks from when we packed it to when it got to TAC, which is respectable. Much better bandwidth than we would have gotten actually, doing it over whatever connectivity we could have gotten at Arecibo. So this is a story of not the able or willing, but the desperate. They really needed help. They reached out to a team that they thought could help them. We came up with a solution. It wasn't the solution we would have picked. It was the solution that we could make work in the environment that we were in. So part of what my story is the group that I work with right now is able and willing to help in other settings. We would prefer you not to reach out and say, hey, I found a whole bunch of tapes in my office from some professor who was here in the 70s. What can I do with them? Which now happens because I give talks like this. But if you are looking to move your data, if you want your data to be more accessible, if you want to try to figure out, okay, so my data is in the cloud, and I've heard that really bad things have happened to cloud data. If you're at NOAA, people know what I'm talking about. We can help you figure out a better way to have your data accessible to your community and to have backups of it or copies of it as you need it. So this is me. And worst case, we will see you in Austin next summer.
Okay. I'm gonna take this off. Hello, everyone. My name is Yuvi. I'm one of the co-founders of a nonprofit, 2I2C. I'm also one of the core maintainers of the Jupyter Hub project. But what I'd really like to be known for is I gave a talk at SciPy called "You don't need to contribute more to open source, you need to go to therapy." So this is also a story. It's a story about me. So that is me on the bottom right with that beaming smile with my brother and my parents. And that's a very happy looking child, right? But this is also me a few short years later with a 1,000-yard smile, stare, and like a look of a dissociated little child. And I asked my dad, recently, like, what happened? Like, how did I go from that to this? And he said, well, maybe you just started noticing the realities of the world you live in. And I know I'm not the only child who's, like gone from that smile to this stare upon noticing the realities of the world you live in. That's billions of children. That's maybe many people in this room. And it's definitely a lot of people who cannot be in this room for one reason or like the other. So it's a common occurrence, right? And I think when you grow up in an environment like that, I was in, with experiences like that, it affects how you see the world. It affects the skills you pick up as you go through life in whatever way or form. And for me, it was like there was a natural attraction to its open source software. It meant that you can't really afford proprietary software, and if it was being given to you for free, you have this strong cultural memory that when something is being given to you for free, it's because there is the desire to extract some value out of you that is, you don't know, maybe you don't know what that is yet, right? But it's coming, you know, and it may be not directly extracted from you, maybe it's extracted from your community, but it is a transactional relationship, right? Like, and those are not necessarily bad, but you have the cultural memory of being able to read through marketing and being like, right, that's what you say, but what do you actually want, right? That there isn't really like, and this is fine, right? Like, it's okay to have transactional relationships, but you have to recognize them for what they are, and you grow up with a cultural memory of that. So there is, in fact, such a thing as a free lunch, but it doesn't come from a company. It comes from your community. It comes from the community that you're a part of, that you help to grow the food for, that you help to cook with, so that it's not just free for you, but free for all of the other people around you. So I ended up, ended up contributing to a lot of open source from a really young age, but not academia, right? Like, because that wasn't even like an option. So I ended up with Wikipedia. I ended up eventually working for them. I was part of their ops team. The one on the left is the Wikimedia Cloud logo that I was part of the team. Wikipedia, you know, is a huge website, right? It's still a top 10 website in the world. And at that time, you know, like, we had an ops team of only 15 people. That is like wild, right? Like, websites that are much smaller, usually, like, they have sometimes operations team that are like thousands of people running it. So I was the least experienced, youngest member of that team, but I learned so much in that environment, right? Like, and it was informed by both my life experiences and those of the people who were there with me, right? I learned technical skills around operating large-scale infrastructure. I learned community building skills. I learned conflict resolution skills. And, you know, I'm sure I picked up a lot of bad habits as well. But, you know, there was also a lot of good stuff that I picked up. And I'll also just explicitly name, like, you know, like, all these wonderful people who have contributed to who I am now, right? Like, and Sumana Harireshwara, Ori Livne, Faden, Brian Davis, Ryan Lane, but there were many, many, many people who contributed both towards, like, I want to be like that, and also, like, not like that. You know, so you have your own unique life path that brings with you your skill sets that maybe you don't even know that you have, but, you know, you come with. And then, you know, like, fast forward to about 2015, and I was feeling a little restless. You know, there was like, oh, I want a little bit more fulfillment in my life than what I've been having. And I was just looking around and exploring, you know, like, places that were unfamiliar to me. And academia is definitely one of those. And I ended up at UC Berkeley through both privilege and luck, where I was just wandering around, you know, talking to people. And they were trying to cross a chasm, right? I mean, that's not what I would have said at that time. That's what I would say now. And the chasm is, well, we have thousands of students, no prior programming experience. We recognize that data science is a different thing than programming, and we want them to be able to learn that. And we want to be able to teach that, right? And we are working towards making that happen. This is 2015, right? So this is like the leading edge of, like, pushing all of this and making all of that happen. And, you know, there was a large number of people with amazing experiences there, right? Like, there was Catherine Carson, who's like one of the best leaders I've ever worked with. There was a lot of extremely pedagogically talented instructors, Ani Adhikari, David Wagner, John De Niro, and some wonderful infrastructure people, you know, who have a lot of experience delivering these kind of things at university scales. But, you know, like, this is they were still, you know, like, working on, like, how do we actually do this, right? And you don't know how you're going to cross the chasm until you have actually done it, right? It's like at the beginning. And this is where, like, you know, like, my skill sets I realized were very helpful, right? Like, this is sort of like, the English Wikipedia gets like close to 300 billion views, and they were trying to, like, deal with, like, oh, we have 200 users. That's so many users. How do we provide computing infrastructure to all of them? And, you know, like, while I was the least experienced member of the Wikimedia ops team, I had all these skills that I didn't realize I had, because I was surrounded by people who had more of that and much more intensely than I did. But I could come here to an unfamiliar space and be like, oh, I have skills that are extremely valuable that I can contribute towards this collective effort to crossing this chasm, right? And again, these are different sets of problems. I'm not, like, trying to, like, you know, be like, they're the same. But I want to, like, just emphasize, you may have skills you don't know you have. right? Because it's like fish to water, like what is water? And we did cross that chasm, right? Like it went from about 200 students. This is like a picture I love. It's, like this is sort of like vaguely fire marshal unapproved classroom because, they have 1,500 students in that classroom, right? And this grew like very quickly because, as you can see, like, basically what was called data science at that point is now called AI, right? Like, and then it's just like the beginning of the hockey stick. And we all together really successfully did, in fact, cross the chasm, right? Like it was the fastest growing class, and it eventually just sort of metasized into its own college. Like UC Berkeley has its own college now. And I didn't cross the chasm myself, and nobody did, right? We all crossed it together. I love the great man theory because of how wrong it is if you look up through history, right? Like none of it was any of us together, but none of us could have done it without literally everyone else. But that was not enough, right? Because UC Berkeley is actually a rich university, no matter how the people there actually feel, just in the global scale of things. And I knew that I, as a young person, would have never had access to UC Berkeley, right? And there's billions of people still like me. And it was important for me to be able to help all of them cross their chasms that I may not know about, right? And I also knew from my prior open source non-academic experience that a lot of successful projects are extracted out of specific chasm crossings. Django is the most popular example for me because it started out in 2002 because there was a bunch of people building a newspaper website in Kansas City. And then they were like, oh, we were really successful in this. We have crossed this chasm. Let's extract that out so that other people may use it to cross their own chasms. And that was how one of basically the most successful Python web framework was formed. So we're like, all right, let's go do that, right? So we extracted the infrastructure that was like powering this out into Zero to Jupyter Hub, and then helped build a community around that. Again, this is not something that is done by just me. It is done through collective effort of many, many people. And I'll just name some, Carol Willing, Chris Holgraf, Min, Simon, Ryan Lovett, Eric Sundell, and many, many, many others. And again, we all brought different skill sets into this. And I would say we have successfully crossed this chasm because Zero Jupyter Hub is used everywhere. And it is a tool that you can kind of take for granted so that people don't even mention that, right? When there is a closing keynote at a conference, nobody says, oh, thank you for all the electric wiring that has been here so we can see each other's faces, because it's infrastructure, and the biggest compliment for infrastructure is when nobody mentions it, right? And we've reached that. And that is because we were all able to bring our various set of skill sets, community, technical, and extract it out and then be able to do this, right? And it is a very deeply fulfilling experience. These are just some of the projects, that are using this, that they're doing their science for, that they're doing their education with. But even more fulfilling is the thousands and thousands of people who are using it and I don't know about, right? I just discovered today that there are YouTube videos of people teaching this from people I've never heard of with tens of thousands of views. And if I go back to why I found the data 8 people, because there was a sense of restlessness, right? There was a sense of I want a little bit more fulfillment in my life. So crossing chasms is really fulfilling, and I highly recommend it. And you will not be able to do it by yourself, but even though however small a part you play, it feels extremely fulfilling. So. And I know Julie mentioned this a little bit. Now, me and many others, we started a nonprofit called 2I2C to sort of, not be vendors, selling bridges that people can cross chasms with, but sort of be partners who can contribute skill sets and tools and expertise that are, through our lived experiences, different than what many people here have, so that we can cross chasms together. Right? So here's the takeaways, right? First is you have skills and tools because of your unique life path, and you most likely don't know what they are, especially if you haven't, sort of jumped around and been in rooms full of people who you don't know and who you are completely unlike, right? That is how you know what you have. So that is important to remember. crossing chasms always requires a multitude of skills, right? It is never, nobody invents a thing by themselves, right? It is just not possible. So they always require a multitude of skills. And so find people whose life paths don't look like yours, to cross chasms together with, right? Because that is both gives you a higher likelihood of actually crossing chasms with, like just from a personal perspective, the fulfillment that comes with, but, also you're much more likely to actually cross the chasm all the way through if you have, like all of the skill sets that you actually need to do that. And then two is, a group somewhere may be missing exactly just your skill set, to cross some chasm that you don't know currently exists, right? So explore the unfamiliar, right? Like I think there is a deep-rooted feeling in us to find familiarity in places, and often that looks like, oh, the thing that you currently do. But there is the familiarity of feeling that is, like, oh, we may have come here through different paths, we may be doing different things, but we all feel the same. And you will find that in lots and lots and lots of places, right, that you may otherwise feel like uncomfortable being in. So, go to different types of conferences if you can. Go to like free events from different communities, participate in different online spaces, make yourself comfortable in being in unfamiliar situations, and look for places where you can contribute whatever you have to other people crossing chasms, because as soon as you do that, they are no longer other people, right? They're just like people you're crossing chasms with. And that is deeply, deeply fulfilling. And when people say, oh, I'm here for the community, to me, that is what that means, right? Like, it's like, there are many different chasms we can cross together. And, together we can go where none of us can actually go alone. So that's it. Thank you.
Yay, thank you so much, UV, Jen, Eli, for these amazing stories. And we're just gonna sit up here and have a panel discussion, both live in the room and online. We can talk to each other. I'm thinking, let's put this slide back. Yeah, together we can. I'll sit with it, yeah. Great, thank you. Thank you. Amazing talks. I love the idea of finding partnerships and exploring chasms together. I love that framing. But are there any questions from each other on the panel or from the audience?
Yeah, or comments.
Or
about,
comments.
like, things that resonate and stories you'd like to share.
I have a. So I'm Tom Paris. This is a problem lots of us face, and I'm guessing these aren't the first times you've tried to cross the chasm in your careers. And I know in my career, I have some spectacular failures at trying to do it. And I'm wondering, that someone made a comment earlier about having a ESIP session on failures at some point. But that might be a really valuable lesson too. So I want to do something that I think could potentially scale, and what have we learned collectively about that? And you're trying to say, these were aspects of our success, but
Yeah.
I am a technical person, so when I do my budgets, I always think about how to pay for the technical stuff. And the process stuff is like a new realization for me, and I don't know how to price it, and I don't know how to hire for it, and so that sort of pragmatic signage, I don't know what the right word is, or cookbook would be
So I think
Really
that's really
helpful.
valuable.
Yeah.
And so I think we're going to pass the mic out there and we'll just rotate up here. So, you know, the Arecibo story, I didn't tell you about the failures. You know, we had 5 months of discussion before the first cable snapped. And we knew what they needed to do. And they were like, really? That sounds hard. I don't think we want to do that. Isn't there something else that could be done? And it took the cable snap and an NSF program officer saying, what the fuck, dude? For them to actually be like, okay, I guess we have to ship you the data. And there was a guy there who'd been at Arecibo for 35 years, refused to acknowledge that the funding was ending. So Arecibo now is not a science instrument anymore. It's a $500,000 a year educational center, and it's only that because if NSF stops giving them any money, they have to return the property to its original landscaping, which is, epsilon impossible. So they have to keep paying them a little bit. It's an educational only center with a couple posters, and that's like it. And this guy refused to acknowledge that this is happening. Or like, it's going to happen whether you like it or not, and it was really challenging. And if we hadn't been super persistent and gotten NSF involved and some other senior people, that data would be gone. And as it is, because they didn't maintain their data in a great way, some fraction of those tapes, they're dead. That data is gone. Whereas if they had reached out sooner, like 10, 15 years ago, and partnered with anybody, but they didn't plan that way. So yeah, that's a huge fail. And actually, I was commenting to Denise, I had at breakfast this morning, saw a woman who had been a postdoc in a job that I had before I was at NSF, and I got fired. And I was saying, yeah, but look at all the things that I learned from being fired. I learned a whole bunch about my self-worth and my job. I learned a whole lot about how I could be sneaky because my boss didn't want to hire me in the first place and had been forced to, and he was super sneaky, and so anyway. And then from there I went to NSF because, I wasn't quite sure what else to do. And from NSF, I went to Indiana and, learned a whole bunch of stuff there, and I got recruited to TAC, and now I've got this really lovely situation that would not have happened if I hadn't gotten fired. And we don't talk about those things. You're right. I think that would be a lovely session to have.
Jen, I think you and I are going to propose a session of failures.
Sorry, and I don't know if someone else, I don't, but by all means, talk about your failures.
I'm here to talk about my failures. I'm just kidding. So what Eli was talking about at the beginning in your story, and then what you were saying at the very end, both fit together very nicely, where it was sort of like you need a variety of people and you need to figure out how to find them all and put all of those things to use for synergistic reasons. And then your comment at the very end was, your life journey has taken you and given you these skill sets. So this is more of a comment, and it's something that I would also be interested in talking with you about. There's this book called Playbook for Progressives, 16 Qualities of the Successful Organizer. And it basically has these 16 sort of traits. And I think it's really nice also to share with teams to be like, who are you? What are you? I can't even remember off the top of my head what what the 16 things are, but it's really a good way to kind of, if someone is having a hard time kind of finding what's their role, what's their strength, what do they bring to the table that's so valuable, because every person has that. I think that's a really nice book. So yeah, I would love to talk about how that fits into the framework of all the different ways that you've talked about organizing, connecting people and making things happen, because that's really, that's what we do with ESIP. So very cool, very fun stories.
There are other questions? Go ahead. Oh, okay, yeah. Yeah, I just want to comment on kind of how I personally think of quote-unquote failure, and I put it in quotes because I don't think of quite as failure. I gave a keynote at a graduation recently, and it's like giving advice to the graduates and about, they're just getting started, and these are like undergrads, masters, PhDs, and I was talking about because I work in, use of, climate science in sort of ocean management, how to integrate that. It's part of what I do. And so you can think about oh, Eli must be super depressing. And I'm actually not. But it's part of the failures, the idea of some kind of, that the process is any kind of linear thing, or that you start here and you're like, okay, I need to have hope that I can get there, and then I can go forward because I can see there's some path. That I don't personally think about it that way. And from my whole, career seeing that, I don't have there are a few instances I can think about that, but I can think of so many more instances where it's not like that. That rather, I use the metaphor of skiing trees or walking through, so let's use walking so more people can relate to that. You go in, you cannot see the way forward. In fact, you don't even know if there is a way forward. And perhaps objectively, there is not a way forward. And yet, you step into the gap and you move forward, and then you get blocked, and that's your failure. But you've learned something in that process of running up against the tree. And so you go and you try a different one, and you block again. And you turn around, come again. And in this process, you are changing. You're probably changing the forest that you're in without really knowing it. And so that you keep trying, and then perhaps at some point you're able to make yet another step. You don't know if you can, but you do know if you do not make the step that you will not make it through. And so in my talk, I was saying, how can you have hope? And I said, because I don't need hope. Hope is not what's driving me. I look around me, I see so many successes. I see where people working on things did make change, right? I see the Lake Washington used to be sewage. It is not today because people worked on that for a long time, citizens. It was a long process. So I see that. So I know for a fact that change is possible. So that's kind of like a tweak on what I think about failure.
Also just want to quickly respond to you, which is, I think when I say let's look at other communities, it's also through time, right? I think a lot of open source work is not actually new. We've been doing this as humans for a really long time, just connecting with each other and finding community. And I know, for example, Tyranny of Structurelessness is an essay about, second wave, third wave feminism from the 60s that everyone I know in open source now, this is great. We apply this on our everyday pull request basis all the time. And I also remember reading Homage to Catalonia, which is from George Orwell about his experience in the Spanish Civil War. And then I have definitely felt in the midst of some pull request review being oh, this is like the Spanish Civil War. I didn't actually say that, but it informs what you do or what you don't do, right? So let's definitely look to read from history. And we are not unique, software people definitely have a history of feeling oh my God, we're doing this for the first time. No, you just don't know history, right? So, so I appreciate the call out to books from outside our sphere.
Yeah, I have a question just asking for advice. It feels like right now the chasm's kind of getting bigger, or we're losing opportunities to make bridges. And that personality trait of early adopters being, stubborn, ambitious, I see those people still coming to ESIP, you're gonna find a way. Right, but unless you experience something like ESIP in person, you don't know the value. And so I'm wondering, this year particularly, we're missing like the new cohort of people to have like experienced what this is, to then know, to rally around their organizations, or even just, once they get to a certain level of privilege, come anyway, which some people here were. Some people took lousy vacations, quote unquote, to just be here because they knew the value. And I'm wondering if you have like any advice on like crossing the chasm when it's like now maybe only virtual, or yeah, just advice.
So that's a great question. I recently got stuck running a state of Texas networking meeting. And to spice things up, I asked my boss, Dan Stanzione, who runs TAC, and another troublemaker named Henry Newman, who's at Oklahoma. And we basically threw questions at them and made them talk about what they thought about things. And one of them was, in a time of funding chaos, how do you plan when you can't plan? How do you deal with the fact that everything is just thrown at you left, right, and center? And how do you support your team through that? I think this is part of what you're getting to. And they said, well, you fix the things you can fix today, and you hope that it will get better, and you give people time and space, and say, what do you need from us to support you? So my personal situation, I was supposed to move to Austin. Executive order said feds can't move to Austin. Feds can't have to be in their home institution office. My husband is a Fed. We have not moved to Austin. We have given up on that for at least, another 18 months or an election or, something like that. And, I went to my boss, I'm like, oh crap, I had promised you I was going to move out this year. I can't move, or my husband has to quit his job, or I have to quit my job, or all of this. And he's like, no, we're good. We're okay. You're planning to move. I will support you in that. And we'll see, if the state does something dumb, which, it's Texas, we will have another conversation. So you deal with what you can, and, try not to have it overwhelm you. So the lack of an incoming cohort is really hard. I think the January meeting, so I think ESIP has done something really smart post-pandemic, which is they went, instead of, the January meetings used to be in person. They used to always be in DC. And instead, it's a full virtual meeting. And that's been really nice in expanding the community and allowing people who, for whatever reason, couldn't travel to a meeting to be fully there. And so kind of splitting this difference. It's not the same as being face-to-face or running into somebody at lunch, or, I didn't even know this postdoc from my former project was going to be here. I haven't seen her in 15 years. So that's really great. But with the virtual meetings, you can try to find some of that space. We can try to keep recruiting and supporting, the people who haven't been able to experience this yet. There's no predicting what's going to happen. Anyone who tells you, oh, I know what's happening to the budget, for example, they don't know. Nobody knows. So part of it is just kind of keep on keeping on, I think.
Well,
Sorry.
I'm going to do a follow-up on what Jen was just talking about there too, is, specifically with ESIP, she mentioned the January full virtual meeting. ESIP is always in innovating and trying new things with this. This is considered a hybrid meeting. And we experimented this year in like the hub and spoke model. And you only had one hub, and it was relatively small, but it has been very successful. And they felt more connection participating in that hub than and I think everybody there had participated virtually in the past, like in the hybrid mode. So there are ways. It's harder. It's a lot harder, and it's a lot harder to build that connection through solely virtual interactions. And know that we're trying to innovate. ESIP in particular, I know, is trying to innovate, but any ways that we can help build those personal connections even through virtual space, I think it's a really hard thing to do, but a really important thing to do.
Thanks, Denise. Brianna, I'll respond a little bit, thinking more about your question too, and then I think we'll wrap up. We're at time, unless we'll keep an eye out for any last questions. But if your question makes me actually think back to your keynote on Tuesday, which was amazing, and about how, so connecting communities, right? You're running community and climate. There's like the ESIP community is so special. And there are and unique, and it's a community of early adopters, and we know that pattern, what that looks like. So I'm wondering if, we can support newcomers not only through ESIP, but through like your local Python chapter, getting involved in documentation. I've had people coming up asking about how to get involved in Earth Access, helping spend the time on the channeling to help find other resilient communities, because I think just like outside of our earth science world, we're seeing small communities that are networked and liaised is really powerful, more than like one big thing, right? It's many small things that are connected. And I think when we find ourselves in conversations about like, oh, what if we, if we're going to aggregate data by state now, let's make a list of all the places data are by every state. Maybe our first question should be like, who's already doing that? Like, how do we get involved with that? How do we point people to that? And I think that kind of like pause, think about where you can fork or join something, and then help establish that for our own habits, and establish those habits by practicing, by welcoming new folks to these places. I don't know if that, I'll try to say that more succinctly, but I think that we keep saying the power is in community, and I think our power can be connecting across communities and welcoming more people to ESIP and beyond that way. Yeah. Any other? Yeah, okay. Yuvi's going to close us out, and thank you all so much.
I will just say that, open source projects have existed for like decades now with basically zero funding, right? Like FOSDEM is a conference that happens every year in Brussels, 20,000 people plus show up. And it's a completely free to attend conference, right? You don't pay any money. And that's not just because, they have some sponsors, but that's not, and other kinds of organizations have been doing things and building community when they have been actively opposed by the state, for centuries, basically, right? So I think what is useful is to learn from history and recognize where we are and what we are. And we are not just scientists, we are not just developers, right? Like I don't know exactly what we are, but it's not those small boxes. And just sort of like expand the places we can learn from, and then actually do the work of learning from them. I think software, anything that touches software, I think in the last 30 years has suffered a little bit from a form of exceptionalism, of like, we are different. Like, no, we're not. Right? And so I think expanding where we can learn from and build community through, I think is really, really important, as we like get to accepting like the realities of like, oh yeah, it's been 35 years, but the telescope is closing down now. I have to acknowledge that, right? So yeah, all right, that's it.